Hey guys, welcome to another episode of Coding with a Noob. This episode and the next one is slightly different. This one is aimed at Salesforce developers who are building Lightning components. If you're neither a Salesforce developer or not working with Lightning components, then you can safely skip this episode and the next one. I still have a lot of JavaScript concepts to cover, and I will get to them in future episodes. Recently, I gave a talk at London's Calling event. The talk was called 10 Commandments for Writing Spiffy Lightning Apps. The talk was recorded and the video is online on the London's Calling YouTube channel. However, when I watched the video, I could see that I was talking way too fast and I was using a lot of filler words like and ah. This is probably because I was a bit nervous, but mainly because I was trying to cover almost 40 slides in 25 minutes. So I've decided to re-record this talk in two parts where I'll talk a bit more slowly and hopefully with more clarity. So without further ado, let's take a look at the 10 commandments. Starting with Commandment 1, learn JavaScript. I suspect that most of the developers coming to Lightning Framework have a background in object-oriented languages like C++ or Java, or if you're a Salesforce developer, you are familiar with Apex and Visualforce. You may have used JavaScript to add some basic DOM manipulation using libraries like jQuery, but unless you've worked with frameworks like Angular or React, you've probably not built a single-page application using just JavaScript. Of course, if you have, then this commandment doesn't apply to you. So do you understand all of these terms, some or all of these terms listed on this slide? If the answer is no, then you probably need to relearn JavaScript. And why would you want to do that? It's an incredibly important skill to have if you want to write robust and elegant code to build Lightning components. So here are some of the resources to get you started. The first resource is an article from Mozilla Developer Network that reintroduces JavaScript to developers who are using or perhaps misusing JavaScript by copy-pasting it from the internet. The second resource is one of my favorite books about JavaScript that I read when I was learning the language properly. It is available free online, but you can also buy a hard copy. It does a good job of introducing some of the key concepts using examples that you can try inline in the browser if you're reading it online. The third resource is for language wonks. And if you're a language wonk and really want to understand the guts and internals of JavaScript, I'd recommend reading Kyle Simpson's You Don't Know JS series, which is available free on GitHub. Finally, in my humble opinion, the best way to accelerate your learning of a new programming language is to read code written by experts in the field. Reading code written by front-end developers will help you internalize some of the best practices and patterns that you may not necessarily learn from reading a book or an article. I've also posted these links in the show notes should you wish to access them. Let's move on to Commandment 2. Commandment 2 is forget MVC, especially if you're writing Lightning components. Everybody, I hope, knows what the MVC pattern is. And the frameworks we've used in the past, like Spring, .NET, Visualforce, they all follow this pattern. But is Lightning components built on the MVC pattern? In a word, no. There are similarities to be sure, but it would be more correct to say that Lightning components is a component-based framework. It follows a variation of MVC, so think in terms of view controller model. It's quite similar to the MVVM pattern, which if you've come across Angular or React or other JavaScript frameworks, you're probably familiar with that term. So this dual controller design is the key difference between Lightning components and standard MVC. So in Lightning component app bundle, you have the client-side component, which is a view, client-side JavaScript controller, and also helper. You have server-side Apex controller and server-side model, which is our S objects. Now, I don't mean that MVC is a bad pattern. It's not. It's just that Lightning framework doesn't follow the MVC pattern. You need to change your conceptual model when implementing Lightning components. And one way to think about this is Lightning framework has a thick client and thin server, and therefore most of the business logic resides in the view and JavaScript controller. Okay, so hopefully that will help you reorient your thinking about how the framework is structured. Commandment number 3, support accessibility. Accessible software and assistive technology enable users with disabilities to use and interact with the products that you build. Lightning components, or in general Aura components, are created according to W3C specification so that they work with common assistive technologies. It follows the Web Content Accessibility Guideline as well. So most of this stuff is baked into the framework. But here are some tips to make your component more accessible. Tip number 1, set the label attribute when it's available. For example, the label attribute is available for button, menu, input text, input date, input date. So set the label attribute. Use the ARIA described by attribute to associate a help text or error message with a particular field. So in this example, I have a UI input text field, and I've associated the contact output text of tag or a component with the input text using the ARIA described by attribute. And what it does is, if there is an assistive technology that's reading this input text, it would read the value stored in the contact output text. So it would read out, this is an example of a help text. Next, convey audio notifications using the UI message component. So anything you put inside the UI message component will be conveyed as an audio notification. And finally, consider attaching on-click event to elements that are actionable in HTML by default, like anchor tag or button or input. Okay, moving on to our next commandment. This is commandment 4, is understand event propagation. Lightning framework uses event-driven programming. You write handlers that respond to interface events as they occur. The events may or may not have been triggered by user interaction. And there are two types of events: component events and application events. Component events are fired from an instance of the component, whereas application events they are also fired by an instance of the component, but they follow a traditional publish-subscribe model. Component events are handled by the component itself or by component in the same containment hierarchy. Whereas for application events, any component, all components that provide a handler are notified. They don't have to be in the same containment hierarchy. Component events supports capture and bubble phase, whereas application events supports capture, bubble, and default phase. Now you might be wondering what that means. So here's an example which explains what bubble and capture phase means. So what we have here is a grandparent component that contains parent component, which in turn contains child component, and child component contains grandchild component. Okay. So what happens in the bubble phase is the component that fired the event can handle it. So let's say the grandchild component fired the event. Grandchild component itself can handle the event. The event then bubbles up from the source component to the application root. The event can be handled by a component in the containment hierarchy that receives the bubbled event. So in this case, the event will bubble all the way up to the grandparent component, which can then handle the bubbled event. The event handlers are invoked in order from the source component that fired the event up to the application root. Any registered handler in this phase can stop the event from propagating, at which point no more handlers are called in this phase. Okay, so that's bubble phase. Capture is exact reverse of bubble phase. The event is captured and trickles down from the application root to the source component. The event can be handled by a component in the containment hierarchy that receives the captured event. Okay, and event handlers are invoked in order from the application root down to the source component that fired the event. So you can see it's the exact reverse of how bubble phase works. And again, any registered handler in this phase can stop the event from propagating, at which point no more handlers are called in this phase or the bubble phase. Okay, the capture and bubble phases are quite similar to the DOM handling patterns. So they basically provide an opportunity for interested components to interact with an event and potentially control the behavior for subsequent handlers. Okay, so it's very important to understand how these two phases work. This is an example of a component event. So in the first block, I'm defining a component event. I'm using the aura event tag and setting the type as component. You can also define one or more attributes. Attributes are optional, obviously, but it's useful to have attributes to send data when you're firing the event. And then this is how you would register an event. So we have a component called CE notifier, and it's registering the event that we defined, which is CE event. Okay, and then it can, after it's registered event, it can then fire that event. It's same as an example of application event. Again, it's the same tag or event. You just set the type as application. Again, you can set the attribute for an application event, and you use it in a similar fashion to a component event. So again, over here we've got an AE notifier, of which registers the AE event, and it can now fire the event. So here are some best practices when you're writing events. Always try to use the component event instead of an application event if possible. Component events can only be handled by components above them in the containment hierarchy, so their usage is more localized to the components that need to know about them. So, where would you prefer to use an application event then? Well, they're best for scenarios where you'd like two components that are in separate parts of an application and don't have a direct containment hierarchy to communicate with each other. Okay. Next best practice is firing an event in a renderer can cause an infinite rendering loop. So don't do that. It's an anti-pattern. It's generally a good practice to handle low-level events, such as a click, in your event handler and refire them as high-level events, such as, for example, approval change event or whatever is appropriate for your business logic. And finally, if you have a large number of handler component instances listening for an event, it's probably better to identify a dispatcher component to listen for the event. The dispatcher component can perform some logic to decide which component instances should receive further information, and then fire another component or application event targeted at those component instances. Make sense? Cool. I'll stop here for now. I'll cover the remaining 5 commandments in the next episode, so stay tuned. Thanks again for watching my screencast. Please leave your feedback in the comments below, and don't forget to subscribe my channel and follow me on Twitter. I'm @Anoop on Twitter. See you next time. Thank you. Bye.